Hi everyone, welcome to this presentation. This time I'm going to talk about electronic design using KiCAD. And in this video, we are going to see how to create new libraries, both for schematics and PCB. Then how to copy and paste components from other libraries. And then we will see how to create new schematic components. We will see an example creating a diode. Then we will see how to create new components, and for this we will use an example of creating the O41 footprint for a diode. Okay, and then finally we will see an example of how to use these new schematics, these new components in an application. So we open our program, KiCAD, and then go to File and create a new project. Okay, so we are going to save our project. For example, we are going to name it as example. Okay, and now we are going to create new libraries, one new library for both schematics and another one for the PCB. So for the schematics, we go here, symbol editor, okay, press here, and then we enter in this new window when we can see all our different libraries with the different components and so on. Okay, so in order to create a new library, we go here, File, and New Library. Okay, so we have to give a name for our library. It is useful to add the letters AA at the beginning. So we are going to have our library on top of the list, and then the name of our library, for example, my SCH library. Okay, something like that. We select here if this library is going to be in global for any project or only for this project. Let's say that we want this library to be global, so select OK. And then we have here our new library. Okay, if we press here, we don't have any component yet. Okay, but we can add right now new components to this library. Okay, so it is very useful to have our own libraries, both for schematics and also for PCBs, because usually sometimes it takes a lot of time looking for the right components and the right device and so on. So it is very useful to have our own library with the components that we use more commonly. Okay, for this we can go to any library that we have ready. For example, here comparators, and we can select this one, LM311. Okay, and then if we use this a lot, then we can do like this, select copy the symbol, and then go to our library, okay, which is this one right now, okay, and do paste symbol. Okay, so with this we have already in our library this new component, okay, the LM311 and this one, which is equivalent. Okay, so this is good because we can select components, I don't know, for example, CPU. If we are using the SID80 CPU, then we can again copy this symbol and take it to our library and just do paste symbol, and we have here in our library, okay, this new symbol. Okay, so with this we can create our own library with the components that we use more commonly. Okay, so right now we just save, okay, and we have here our library. Okay, we can do the same with PCB libraries. Okay, so for this we go here, footprint editor, okay, press, wait a little bit for the program to load all the footprints and all the libraries. Okay, so we have here now again all the libraries with the different components in the program, and the same theme. If we need some components, then we have to look for them in the different libraries or do a search here, and this usually takes time. Okay, so it is better to have our own library at the beginning. For example, I have this one here with the components that we use more commonly. Okay, so we do the same: file, new library. Okay, give a name to our library. Okay, for example, use AA again to have it on top of the list, and then my PCB library. Okay, and then save. Okay, again, we can say that this is a global library. Okay, and then we have here ready our new library. Okay, and same thing, we can go to other libraries, connector, for example, select some connector that we are interested on, for example, this one. So do copy, okay, with right click, copy, okay, and then go to our library and right click again and paste footprint. Okay, so we have here our new footprint, okay, our new component. Let's do it another time. For example, I don't know, maybe we can go to display, okay, and see some display like this one. We use this display, so we do the same. We have to select only the component, copy, okay, and then go to our library and select paste footprint. Okay, so we have here again our new component, PCB component. Okay, so this is very useful. It is worth to take a look to all the libraries and select the components that we use in our PCBs more regularly, and then make our own library with these components. Okay, but now we are going to see how to create our new components if we want to create one component that is not available in any library. So we need to create a new one, both the schematic and also the PCB component. Okay, let's see then how to create a new symbol for schematics. Okay, for doing this, we go here to this button and click here on symbol editor. Okay, so this is going to start this new window where we have our new library, okay, that we have created before. Okay, is this one, so with the new components that we have created. Okay, in order to create a new symbol, a new component, we go here, file, and new symbol. Okay, and then we have this window. We have to select the name for our symbol. We are going to do a diode, so we select diode, the default reference designator, which is D for diodes, and then the rest of the items we can leave them by default. Okay, so press OK, and then we have here the window to draw our component. Okay, so we can move this a little bit. For example, the name of the diode. Let me try again, move. Okay, put this on top, and this other one, oh, sorry, see, and this other one here. Okay. So now what we have to do is to draw the body of our diode and then to place the pins of the diode. Okay, so for drawing the body, we go here. Okay, select add lines. We are going to do a simple drawing like this. Okay, double click to end the drawing mode. Okay, and then we have this drawing for the body. Okay, if we want to change the thickness of the lines, we can double click and then select here, for example, 10 mils in order to draw it a little bit thicker, this part, or even if we want also this other part. Okay, so with this we have ready the body of our diode. The next thing that we have to do is to add the pins of our components. Okay, so for this we go here. Oh, sorry, is place here. Okay, and then place pin. Okay, we can do the same things using this button here on the right. Okay, add pin to the symbol. Okay, now it's selected the tool, so we click here and then we have this new window to select the properties of the pin that we are going to place. Okay, let's play it first, for example, the anode. So the name is going to be A and the pin number 1. The electrical type, we have several possibilities. This is important for later checking the different rules and to detect errors and so on. In this case, this is a power device, so we can select passive. Okay, we can select passive for the pins. Okay, and then the rest of the items we can leave them okay as default and press OK. Okay, so we can place the pin like this. Okay, so we can see that the number of the pin is 1. Okay, this circle here is showing where the connection is going to be made into the circuit. Okay, and we can see here also that this pin is the anode. Okay, but this is not very good. We are going to remove later this the name of the pin. Okay, and leave only the number of the pin. Okay, but let's add first the other pin. Okay, so click here and then we are going to place the cathode. Okay, so it will be okay for the name. Okay, the number is going to be 2. Okay, then passive again and the rest of the items by default. Okay, now we have to rotate. Okay, with the letter, pressing the letter R, we can rotate and put it in this direction, which is better because the connection, remember that the connection is the circle of the pin. Okay, so probably we don't like to have here the names of the pins A and K. Okay, so we can make this invisible. Okay, for this we go here, edit and properties, select properties. So we have here different possibilities. One of them is if we want to show the name of the pin. Okay, so we unclick this, we deselect this. Okay, so we click OK, and now we can see that we are going to have only the name of our diode and the designator. Okay, usually I think it's better to put the designator here on the top and the name of the diode. This is going to be the reference. Okay, say for example 1N4148 or whatever the reference of our diode, the part number of our diode is going to be. Okay, so we can save now and we have ready our new component. Okay, for schematics. So now let us create the component, the symbol for the PCB. Okay, better said, the footprint for the PCB. okay? In this case, it is a little bit more complicated because we need to know exactly the dimensions of our component, okay? We can get the dimensions from the manufacturer, or we can just have the physical components and measure the different dimensions, okay, on the real component. Here I have selected this footprint taken from a manufacturer datasheet, okay? And this is this footprint, DO41, okay, with these dimensions here. And from these dimensions, we can get the dimensions for our footprint, okay? For example, in this case, we are going to use this pad with holes of 35 mils. The diameter of the pad is going to be 70 mils. The distance between the pads is 500 mils, and the dimensions of the body is 300 mils. Okay, it's going to be something like this. Okay, so using this as a reference for our design, then we are going to create the new footprint. Okay, so let's go to KiCAD again. Click on Footprint Editor. Okay, and then we enter in this window where we have our new library that we have created with the different components. Okay, so we go to File and New Footprint. Okay, or we can select this button here, New Footprint. Okay, and then the footprint is going to be the O41. Okay, so we have here our new components. Okay. So we can move here a little bit and this a little bit, okay? Now we have to take into account that this is a physical drawing, okay? So we have to take into account all the dimensions of our footprint. We have here the reference, the origin, okay, of our drawing. And here on the bottom, we can see the coordinates of the cursor. Okay, so this is very useful for doing measurement and doing the drawing correctly. Okay, so we go here and then we have here the origin. Okay, so let's start, for example, for the path corresponding to the anode. Okay, so we go here. Okay, click Add Path. Okay, and then place the first path here. Okay, and then the second path. If we go to our design, the distance between the path is 500 mils. Okay, so you go here. So this is the reference 0. Looking at this, okay, coordinate, then we can see, we can measure 500. So we need to do a zoom and locate this in 0.5, okay? And with escape, we have here our two paths, okay, with the correct distance, which is 500 mils, okay? We have to pay attention that we need to select here the dimensions, okay, the units to inches, okay? This will be the units in millimeters, okay? So we need to select here the units in inches, okay? So with this, we can draw now our component, okay? So the next thing is the body of the component was here, okay? So we have 300 mils, okay? So we go to this position of 100 here, okay? Because we have 100, then 300, and another 100 here is 500, okay? In order to draw the body of our component, then we need to select the corresponding layer, okay? So we need to go to place, okay, align, okay, and the layer in which we are going to draw the body, which is the front silk, Okay, so this will be the layer to be selected, okay, because our drawing, our component is going to be on the front plane, okay, in the front seal screen. Okay, so we can go here 100 and then start drawing. Have to select the tool and then start something. Let's say that we are going to use something like this. Okay, until 400. Okay, and then with escape. Okay, so now we add some drawings for the wires like this. Okay, and then we add the another line here to indicate that we have the cathode in this position. We can select the paths in order to check that the dimensions are correct. So for our paths, we have selected 70 mils for diameter and 35 mils for the hole. Okay, so we select here the sides, 70 mils and then 35 mils for the hole. Okay, same thing with the other one. Path number 2, side is 70 and hole side 35 mils. Okay, what is very important is that the number of the paths here has to be the same as the number of the pins that we have in the drawing of the symbol for the schematics. Okay, so we have used 1 for the anode and 2 for the cathode. Okay, so if we go to the symbol editor, okay, in our component here, okay, the diode that we have done, we have here 1 for the anode and 2 for the cathode. Okay, this is very important in order later to use the both components together for doing a PCB. Okay, when designing our footprint, it is also important to add a drawing corresponding to the core jar of our component. Okay, for this we go to this layer here. Okay, front core jar. Okay, in order to define the total area of our component. Okay, so we select here. Okay, this one, and then it is good always to draw with a rectangle or with lines to draw the code jar corresponding to our component. Okay, this is very interesting for later checking that there are not components that are too close together, and this will make difficult the manufacturing of the board. Okay, so this is important because we can use this later to do the checking of the different rules, and then it is going to detect if two components are too close. Okay, so this is also important. So let's save now. Okay, and we are ready to test our two components in a new design. So now let's do an example of using the components that we have just created. Okay, for this we go to our schematic example. Okay, and then we are going to create a simple PCB. Okay, that is going to be a full rectifier, for example. Okay, so we go to place symbol, okay, here on the right, and then click, okay, and then we select our new library. Okay, this one, select diode. Okay, this is the diode that we have created, and then rotate, and then we are going to create we're going to create a full rectifier. Okay, now we can copy both of them, okay, with copy block and then paste, okay, and then we are going to need two connectors. Okay, so go to place symbol again. Okay, I'm going to select components for this other library, for example, this connector here. Okay, rotate, and then again. Okay, so now we can do the wiring. Place wire, this button here. Okay, so we can do all the required connections like this. Okay, and this will be the DC part. Okay, so remember that it is very important to name all the nets. Okay, so we can add a label, okay, to all the different nets, especially the most important nets. For example, here we can say we can name this as AC1. Okay, this other will be, sorry, this other will be AC2. Okay. And this will be, for example, DC plus, and this will be DC minus. Okay, so we are almost ready. And now we can annotate all the components to get the different numbers for the references automatically. Okay, so for this we go here, tools, okay, and then select annotate schematic. Okay, so we can leave everything by default and just say annotate, okay, and then close. So we have all the different components annotated. Okay. And then now if we like, this is very simple circuit, but usually in a general circuit, it will be important to go here to inspect and do the electrical rules checker. Okay, so we press here and then run, and we will see that we don't have any error. Okay, so everything is okay. So we can go to the next step. Okay. The next step will be to assign the footprints to the different components. Okay, so we go to the connectors, for example, and then we are going to use, already it is selected, this connector CON2. Okay, so this is okay, and this one is okay. So for the diode, we can double click on the diode. There is no footprint here by default. Okay, so we can go here and select our library, okay, which is this one, the new library that we have created with our component DO41, and do double click and select this component, okay, and do the same for the others. Okay, so select footprint, our component, the 041, or we can copy the name of the footprint and the library, okay, and paste in the other two diodes. Okay, just save. And then now we can go to the PCB, okay, and transfer all the components to the PCB and do the PCB, okay. So for this we can even go here, tools, okay, and then say update PCB from schematic, okay. So do like this, okay, update PCB, we get this window, select here, click update PCB, okay, and then close, and then we have here all the components ready for doing the wiring, okay. So we only have to move the different components. For example, this is J2, this is J1, okay, rotate with R, okay, so we are going to place like this, and this other component, rotate like this, for example, and then the diodes, this is D1, and this is D2, this is D4, and this is, okay, D3, okay, so we have here our PCB. We can do a zoom, okay. And then just we have to do all the wiring. Okay. And you can see that we can see here the core jars of the different components. Okay, if we make, for example, we can make a test of this. If we do the design rule check here, the design rules check, okay, click here, then we are going to see that we don't have any problems. Okay, we run the DRC and then everything is okay. Okay. This is the different things that it is checking, okay? But for example, if we place this diode very close to the other one, so the two core jars overlap, then we are going to see that we are going to have an error in our design rule checks. Okay, so we click here again and run DRC, okay, and then we get this error here, okay, that there is a core jars overlap between D1 and D3, okay. So this is also interesting to avoid this type of mistake. Okay? And you can see that we get this red arrow here, okay, to indicate where is the error. Okay, so we are going to move this. And then now, yes, we need to do the wiring, and also if we want the drawing of the PCB. Okay, sorry, we have to select line to do the drawing of our board. Okay, like this, and we finish there. Okay, and then now just to do the wiring, okay, we can use the bottom layer for the wiring. So we go to bottom, okay, and start doing the wiring. Okay, again, if we want to increase the thickness of the track, of the different tracks, then we can go here and edit predefined sizes. Okay, and then we can add, for example, a size of, this is very simple, so we can use even 50 mils, okay, and then we can start doing the drawing. Okay, but we have to select bottom layer and then 50 mils. Okay, so now we need to select the tool corresponding to the root, to tracks. Okay, not the one corresponding to graphic lines. Okay, to do the routing we need to select this one, root tracks. Okay, so we select here and then now we can do it. Sorry, but we need to select bottom layer. Okay, so we select here and then we can do the routing of our board. Okay. Okay, so with this we have everything routed, and then we can do the design rule checks again to see if there is something wrong. Okay, run DRC, so we can see that everything is okay. Okay, so close, and this is our board ready. Okay, many times it is interesting to do a fill, okay, in our layer, in our board. Okay, so we can do this using this this button here on the right, add fill zones. Okay, let's see how to do this. Select this tool and then, for example, we are going to draw our fill area in our board. Okay, on the bottom layer we select here the layer, in this case bottom layer, and then we can select is this field area is going to be connected electrically to some of the nets. In this case, for example, it will be good to connect this to DC minus, okay, which will be the ground level. Okay, so we select this and then we have the other values and so on. We can keep them by default right now. Select OK, and then we can start drawing the fill area. Okay, for example, we are going to do a rectangle. Okay, like this. Okay, so right now we can see that we have our field area here, okay, connected to the ground, okay, to DC minus. Okay, if we want to see the components, we can select the front seal screen, okay, and then we can see all the components. Okay, if we don't want to see the courtyards, then we can go here and click here and select this. Okay, and then we can see better our board. Okay, so with this we can print or we can generate the Gerber files as we have shown in the first video of this series, KiCAD. Okay, so we have already now our board. Okay, so with this I finish this video today. I hope it has been useful for you. If you have interest on this type of videos or electronic design, just leave me a comment below and I will try to answer any comment from you. Okay, thank you very much and see you in another video. Goodbye now.